Hello everyone, my name is Mahsa Ardakani, and today I'm going to be presenting our demo PiCASo Integrated Conversational AI for social robot with optimized LLMs. Recent advances in LLMs like Phi, Llama, and Gamma have made language understanding more powerful than ever. Whisper models enable real-time speech-to-text transcription on edge devices, and with frameworks like Llama CPP and Whisper CPP, we can run these models efficiently on low-power devices like the Raspberry Pi, enabling real-time conversational AI without relying on the cloud. The motivation behind PiCASo is to enable seamless, private, and real-time voice interaction with AI, particularly for educational and assistive applications using social robots. But LLMs are typically too large and power-intensive for direct deployment on edge devices. Our approach was to build a full conversational pipeline, including speech-to-text, model inference, and text-to-speech that runs entirely on a Raspberry Pi 5. This means no GPU, no internet, and no cloud. So everything is local and private. We use a Raspberry Pi 5 with 16 gigabytes of RAM and a quad-core CPU with an M2 hat for fast non-volatile memory storage. The system handles everything locally from input to whisper, quantized LLMs, and Piper text-to-speech. To enable fast and memory-efficient inference, we applied uniform post-training quantization. Weights are quantized to 2, 4, and 8-bit, and all activations are 8-bit. We've tested several LLMs including Llama, Gamma, Phi, and BitNet models, but for this demo we are showing Phi 3 in full precision with 3 quantized variants, Q2, Q4, and Q8. Quantization helped us to reduce the memory footprint by up to 4 times and speed up token generation, while keeping an accuracy in real-world question and answering tasks. Okay, now let's take a look at the demo, where we compare 2 versions of Phi 3 models, one in full precision on the right side and the other quantized to 8-bit on the left side. Both models are given the same prompts and context. To fit our presentation time, we will sped up the video by 5 times, but all the measurements and conclusions are based on the actual runtime. Right from the beginning, you will notice a clear speed difference. For example, for question 1, Q8 model finishes generating its response in about 28 seconds, while the full precision model is still generating. For question 2, Q8 completes the response in roughly 17 seconds, while floating point model takes longer. And it continues this way across multiple prompts. The Q8 model consistently finishes generating responses earlier, showing a significant improvement in response time without any major drop in quality. This speed advantage is especially valuable in real-time applications where delays can interrupt the natural flow of conversation, especially in voice-based interfaces. This slide shows the first stage of our real-time pipeline, which is capturing audio from the microphone and transcribing it. In this example, I asked a math-related question that aligns with the context already given into the system. As you can see, the transcription is very accurate. Once the transcription is done, the question is forwarded to the selected model to generate a response. In this example, the quantized Q8 model was able to generate a complete and accurate answer in 26.15 seconds. This is our live interface running on the Raspberry Pi. It shows the transcribed question, the LLM's response, and the total generation time. Users can switch between math and geography context and hot swap between different models. We also track tokens per second and Nubia score to measure speed and accuracy in real time, all fully on device. To demonstrate a real-world use case, we show our full conversational AI pipeline running on Obi. Obi is a commercially available social robot from Van Robotics. Obi is designed for classroom environments where it supports and engages students through interaction communications. Obi has a Raspberry Pi inside, making it a perfect fit for our deployment. The full pipeline runs directly on Obi. This enables Obi to listen to students' questions, generate intelligent responses, and speak them out loud, all in real time and offline. That makes it ideal for privacy-focused and bandwidth-limited educational settings. Thank you so much for your time and attention.